Hi there, welcome to Chapter 2. We're going to talk about isotopes this time. So, we talked about how elements were composed of electrons, neutrons, and protons, and protons were had to do with the atomic number. Okay, or protons had to, sorry, protons had to do with the atomic number, and you had the same number of protons as you did electrons. And so then we have something else that we need to talk about now that called the mass number. And since most of the mass has to do with protons and neutrons, the mass number of an element is the number of protons plus the number of neutrons. So if you have, for example, chlorine, which has 17 protons, it has, and we experimentally know that it has 35 atomic mass. So if we know that its number is 17, that's the number of protons it has. So we know it's also got 17 electrons because it has to be neutral, right? Pluses and minuses. And then to understand the number of neutrons, what we have to do is we say, okay, since protons and neutrons are what make up the mass of the nucleus, thus the mass of the atom, then we can say the atomic mass, in this case 35 minus 17, tells us there are 18 neutrons in chlorine. So I know I have 17 protons, and if I have 17 protons, I must have 17 electrons. If I know that the atomic mass is 35, then I also know that 35 minus 17 tells me the number of neutrons. All right, so mass, which is A, minus the number of protons, which we said before was Z, remember? And that will give you the number of neutrons. Notice in this example that I have two chlorines here. I have chlorine 35 and chlorine 37. The difference between these two is that if the mass of this one is 35, that means I have 18 neutrons, because 35 minus 17 is 18. But if I have a chlorine 37, that tells me that the mass number is 37. That tells me that 37 minus 17, because the number of protons don't change, this has 20 neutrons. Wow. The difference between those two, they're both chlorine because they both have 17 protons, but since they have a different number of neutrons, they have a different mass. And those are called isotopes of each other. So chlorine has two isotopes, chlorine 35 and chlorine 37. When you look at the periodic table, you're going to see the atomic number on the top, the symbol, and then you're going to see atomic mass. And now you're going to say, hang on a minute, you just told me that the mass was the number of neutrons plus protons. Well, you don't have 0.01 proton or 0.01 neutron. You're right, I don't. So if I was looking at carbon and I was saying, okay, the mass is about 12 of carbon, okay? So I have 6 protons because the number is 6. I have 6 electrons because they have to be neutral. And 12 minus 6 is going to be 6 neutrons, okay? And that's how you tell me how many protons, electrons, and neutrons are in there. But what you'll notice when you look at the periodic table, that those numbers that are atomic mass, they aren't whole numbers. They are 12.5 or 13.7, or sometimes they have like 4 decimal places, okay? So where does that come from? Well, that's because the atomic weight that we are expressing is called a weighted average, because there are multiple isotopes of every single element. So carbon can be carbon 12, it can be carbon 13, it can be carbon 14, okay? But there's a whole lot more of carbon 12 than there is 13 or 14. So instead of just doing a regular average and saying 12 plus 13 plus 14 divided by 3 would be 13, we can't do it that way because the weighted average has to take into consideration how much of each one I have. I'm going to show you how this is done because I want you to understand it, but you're not going to have to calculate one of these. Okay, so rest assured. So I have our example earlier was chlorine 35 and chlorine 37. The actual mass of those when you measure them to the nth degree is 34.97 and 36.97. Because remember, we use math to describe things. So it's not perfect, but it's darn close. 34.97 is really close to 35 and 36.97 is really close to 37. So, okay, we can deal with that. But when we look at the abundance, okay, that is how much is actually chlorine 35 as opposed to chlorine 37, then we say, okay, well, there's 75.78% naturally occurring chlorine 35 and only 24.22% naturally occurring chlorine 37. So I can do an average basically by multiplying the AMUs times the decimal percent plus AMUs times the decimal percent, and that'll give me what's called the weighted average, taking into consideration that if these were 50-50, I could just divide by 2, right? I could add them and divide by 2. Unfortunately, they're not, so I use this weighted average. So instead of saying there's 50% chlorine 35 and 37% chlorine 37, I say there's 75.78% chlorine 35, and the rest is it. So basically what I'm saying is we take the AMUs times 75.78%, and that gives me that many AMUs, and then the 36.97, which was only 24.22, gives me 8.941 AMUs. These have 4 significant figures, okay? So I can have 4 significant figures in my answer. So 35.45 is what you'll see on the periodic table because that is the weighted average of chlorine. And that's it for isotopes.